In reality, paint production is a rather complex process. Here, we've simplified the production somewhat. On the table, we've collected the main ingredients of paints. Let us start with the binder. In its original state, some binders are solids and some are liquids. To make a solid binder liquid, we can dissolve the binder in a solvent or a mixture of solvents. The binder and the solvent is called the vehicle of the paint. Here we have a liquid binder. We add the solvent and mix well. The next step is to include certain raw materials to a proportion of the concentrated mixture, such as additives, which are important for dispersion and anti-settling of the pigments. Usually, they are added under high-speed agitation to ensure an even distribution of them in the vehicle. Extenders are added to reinforce the paint film and to give the paint the correct gloss and consistency to make it suitable for spraying, rolling and brushing. The colour pigments will give the paint the desired colour. During production, the solution will be tested to see if the particles are fine enough or whether it's required to disperse for a longer period of time. To this solution, add the rest of the vehicle and additives. Finally, the viscosity is adjusted to the correct level by adding solvents. The paint is then ready to be tinned and shipped to the consumer for application. The binder is the most important part of the paint. To a large extent, the binder determines the physical as well as the chemical properties, and the generic type of paints are usually named after the binder. To demonstrate this, we've partly used ready-made paints and partly their pure binders: alkyd, epoxy and polyurethane. Let us apply them to some test panels and expose them to different environmental conditions for some time. When examining them after exposure, we can see that they show different properties. Exposed to sunlight, the alkyd has remained fairly glossy. The epoxy, however, chalks due to poor resistance to UV light. The polyurethane remained glossy. When the binder has been exposed to water, we can see that the alkyd has absorbed water and become milky, while both the epoxy and the polyurethane showed good resistance. As an example of the chemical exposure test, we used caustic soda, a strong alkaline solution. The alkyd swelled and flaked off, while the epoxy and the polyurethane showed good resistance. Please note that most generic types of paint are modified in various ways to give improved properties for certain applications. When exposed to seawater, different metals will have different electrochemical potentials. This difference can be measured, and we can rank the metals. If two differently charged metals are brought in contact, electrical energy will start to flow between them, here illustrated by the light bulb. A similar effect is the driving force behind corrosion. Let us imagine, therefore, that we have two dissimilar metals being placed in seawater. If a connection is established between them, electrons will start to flow from the more negative metal to the more positive. At the same time, ions in the electrolyte will start to transport current by moving towards the metals. The negative metal will start corroding. Thus, a corrosion circle is established. The corrosion cell. For corrosion to develop, a corrosion cell must exist. If we break the circle, the corrosion will stop. Protection will be achieved by creating a barrier between the metal and the surrounding environment. An anti-corrosive paint can form such a barrier. Obviously, a thick coat will protect better than a thin layer. Once applied, the corrosion circle will be broken. Blast cleaning is a very good method of pre-treating steel before painting. The better the blast cleaning, the longer the paint system will last. Also, some paint types require very good blast cleaning, while surface-tolerant paints can give good performance even after light blast cleaning. Assessment of a blast-cleaned surface is done according to various international standards, such as ISO 8501. The blasting standards are SA1, light blast cleaning, SA2, thorough blast cleaning, SA2.5, very thorough blast cleaning, and SA3, blast cleaning to visually clean steel. Light blast cleaning removes loose rust, paint and other foreign matter. Further blasting takes you through the different grades up to visually clean steel, SA3. Water jetting removes rust, salt, surface contaminants and old paint from structures. The method utilises very high water pressure, and the handheld types can therefore be very exhausting for the worker to operate over long periods of time. A rotating nozzle consists of several individual nozzles. Based on the condition of the substrate and the specified cleanliness, the assembly of nozzles can be tailor-made to fit the actual job. It's not only the amount of water, but also the fact that the nozzle rotates that makes the cleaning so efficient. Here, 4 different pressure levels are evaluated with respect to cleanliness and production rate. It's evident that to achieve a good result, the pressures should be at least 2000 bar. If lower pressures are used, 750 and 1000 bar, you need to wash slowly or repeatedly, and still the cleaning may be insufficient and the paint may barely be removed. At 1500 bar, the resulting standard is improved, but the production rate is significantly lower than at 2000 bar. 750 bar is to the left and 2000 bar to the right. Wire brushing is one of several alternatives to blast cleaning, where blasting is not permitted or not feasible. Under ISO 8501, thorough wire brushing is designated as ST2, while ST3 indicates very thorough wire brushing. To speed up the production rate, rotating wire brushes can be used. If care is not taken, there is, however, a great risk of polishing the surface, which will give a poor anchor pattern for the paint system and reduce the performance. Corrosion often starts at sharp edges. The reason for this is that the specified dry film thickness is not achievable around sharp edges. Prior to pre-treatment and painting, such edges must be rounded by disc grinding. A reduced film thickness will give a lower barrier effect, and corrosion will initiate much earlier than on plain surfaces. After rounding all edges, a stripe coat should be applied by paintbrush, followed by a full coat by airless spray. Ideally, stripe coating should be carried out prior to each full coat. This method ensures an even film thickness is obtained, and the paint system will give protection for an extended period of time. Poor preparation of the steel will result in early corrosion. This construction shows weld spatters, uneven welds and notches, which will cause problems unless they are ground smooth. The most common tool to use is the disc grinder. but also other types of equipment are available. A painted surface may suffer from damage in only a small part of the total area. The steel inside the damaged area will be corroded and the paint edges will be loose and sharp. Spot blasting is often used to remove the rust prior to maintenance painting. Unfortunately, the intact paint around the damaged area may suffer impact damage. Never paint on such areas without first grinding or feathering the edges of the damaged paint. In this case, solvents from the newly applied paint will cause the damaged edges to curl up. Even after 2 maintenance coats, the rough paint is visible. Damaged paint after spot blasting is a very poor substrate for paints, and corrosion will develop in short time. A better alternative would be to disc grind the damaged areas. A smaller area will be affected, and at the same time the sharp edges of the paint can be feathered. Clean the surface and apply the paint to the specified dry film thickness. Again, spot blasting removes rust but destroys the intact paint around the damage. It is important, therefore, to ensure that edges of old paint are feathered down to intact paint before applying the new paint. If this is not carried out, such areas will suffer from corrosion very quickly. In contrast to blast cleaning, water jetting removes water-soluble salts from the substrate. The removal of salt reduces the risk of osmotic blistering. The salt level is checked by the Bressler method. A patch is fixed to the surface and distilled water is injected through the frame. To get a correct salt level from the measurements, the whole area inside the patch must be cleaned. Pumping the water in and out several times ensures this. Finally, the conductivity of the water sample is measured and recalculated to give the salt content on the surface. Foreign matters on the lid of the paint tin must not fall into the paint. Spray nozzles are very sensitive to contamination, and problems with the application equipment will delay the work. The inspector may also reject a contaminated painted area, resulting in a time-consuming, costly reblasting. Always start by removing dirt and dust from the lid. Open the tin and lift the lid away from the tin to avoid any contamination of the paint. Mix the base well by a mechanical agitator. Add the correct ratio of component B. And remember, not a stick, but a mechanical agitator to ensure proper mixing. Check the induction time and start the application. Proper mixing of 2-pack paints is not easy to achieve. This is easily demonstrated by using this dark-coloured base, and even in a small tin like this, it's not sufficient to just use a stick for stirring. If you do, when you apply paint to a substrate, there'll be too many molecules of the base material in one place and an excess of the curing agent molecules in another area. Therefore, it's impossible for the complete chemical reaction to take place and establish a 3-dimensional network, which means the paint will not cure as it's supposed to. If the relative humidity is higher than specified, it's essential to install a good ventilation system. Always have the inlet at the top and the outlet at the bottom, as solvents are heavier than air and will collect at the bottom. Keep the atmospheric condition under control during the pre-treatment. Throughout the application and during the drying period. Please note that inspections will not always verify whether the paint has dried properly or not. Lack of stripe coating will often lead to early corrosion. This is due to a too low paint film thickness on the most susceptible areas, such as sharp edges, rough welds, notches and other areas difficult to reach. The attack starts as minor corrosion on the tip of the edge, but with time it may develop to a complete breakdown. By using the stripe coating technique, a large majority of the corrosion attacks can be prevented. Make sure to use a good quality paintbrush, which is capable of working the paint well into the substrate. Stripe coating, followed by spray application to the specified film thickness, will give an even paint film, resulting in lasting protection of the steel. Paint is applied to substrates of many different qualities. In general, one should avoid using roller application for the first coat when painting steel, particularly when the substrate is uneven, and it is definitely not recommended. On a surface such as this, the poor wetting ability of the roller will give holidays, most probably pinholes and areas with poor adhesion between the paint and the substrate material. These areas are weak points in the film, and after some time in service, blisters may develop. When they burst, unprotected steel will be exposed and corrosion will begin. Always start with the complex parts. This ensures that the specified film thickness, not too little, not too much, is obtained all over, giving a nice even finish. If carried out in the reverse order, over-application or dry spraying may occur on the large plane areas. In strong winds, the paint should be applied in the same direction as the wind to avoid dry spraying. Cross-spraying is a useful technique to obtain an even film thickness, particularly when very thin or very thick coats are to be applied. Note that the applicator keeps a constant distance between the spray gun and the structure, and that the spray gun is kept approximately at right angles to the structure. When spraying, it is important to release the trigger before the end of each pass to avoid excessive paint thickness at either end. When applying paint, make sure to work systematically. Unsystematic application, as seen here, will result in an uneven film thickness. Areas with too low thickness will result in inferior corrosion protection, while areas with thickness far beyond that specified may give entrapped air and solvents. A similar effect is seen if the applicator does not apply the paint with correct overlapping between the passes. As we can see on the animation, an overlapping of approximately 50% gives an even film thickness for the entire surface. This is also demonstrated by the applicator. Let us see what will happen if too small an overlap is used. As we can see, an uneven film thickness is created, even after cross-spraying, if too long a distance is used between the passes. Likewise, too big an overlap may lead to over-thickness. The major challenge with roller application is to achieve an even film thickness. First, fill the roller with paint and make 2 parallel stripes on the structure. Then cross-roll between them. The final rolling should be carried out by moving the roller up and down in one pass before moving it one step aside and carrying out the next pass. Work systematically. Apply the paint in exactly the same manner on the next area. To avoid shadows and to obtain the same gloss for the entire surface, the final rolling of each area must be carried out in the same direction. here up and down, not left to right. When working with an extension, more or less the same procedure should be used. Apply 1 or 2 stripes of paint with the roller. In many cases, the cross-rolling has to be carried out in a diagonal direction rather than at an angle of 90 degrees to the initial stripe of the paint. Remember to use the same final rolling direction as for the other areas. Spray application requires good technique to obtain a satisfactory result. When starting to apply the paint, the applicator must use a wet film gauge to check that the correct wet film thickness is obtained. Start the measurement by checking that you have all you need and that the calibration certificate for the instrument is valid. Adjust the instrument to 0 on a plain steel plate, and then using a suitable calibration foil to the approximate expected dry film thickness, adjust the instrument again. You're now ready to check the painted surface. Take as many readings as required according to the standard you're working to or as given in the paint specification. Results are recorded manually or automatically. Start the testing by grinding and cleaning the dolly thoroughly. It's advisable to rub the paint to remove inactive layers and to improve the adhesion to the dolly. Remove the dust before gluing the dolly to the painted surface. Make sure you use the correct type of glue and let it cure for as long as required. Using the special tool, cut around the dolly, making sure to penetrate right through the paint down to the substrate. Check that the calibration certificate for the equipment is valid and fix the grip around the neck of the dolly. Increase the pressure gently and record the pull-off value. The test should always be carried out using 3 dollies simultaneously. It's important not only to look at the pull-off value, but also to look at the type of failure. This could be adhesion failure between coats to the substrate or a cohesion failure.